Let's take a look at linear models and scatter plots. And so we can see we have three output windows from a graphing calculator. And in the far left, we have a positive correlation. That means that the points are um, in a pretty linear pattern, and they are, as x is increasing, the y is increasing. And so that's a positive correlation because our points are going in an upward fashion and they're pretty close to a line. And so this value of 0.974 means, or 972, means that it's pretty strong, okay? Our values can be anywhere between -1 and +1. So -1 indicates a strong negative relationship. +1 indicates a strong positive relationship or correlation. Okay, and 0 means no correlation. Okay, and so if you have, say, 0.5, that's kind of a mild correlation, positive correlation. If you have -0.5, that would be a mild negative correlation. And so if you're looking at numbers, let's say on the number line, if you're looking at correlations from -1 to 1, and so here's my -0.5, here's my +0.5, then these are going to be pretty strong. Whoops, that's supposed to say strong. There we go. And these are going to be fairly strong. And then these that are close to the 0 would be weak or no correlation. The closer it gets to 0, the closer it gets to no correlation. And so you can look at this negative correlation we have here with -0.856. And so that's pretty close to -1. So that is a fairly strong correlation, but as x increases, y decreases, so that's a negative correlation. And you can see how close the points are from the line or to the line, and that kind of tells you the strength of the correlation. Okay, the pattern of the points gives you the direction, whether it's positive or negative or no correlation, and then how close it is to the line, and that's like the line of best fit, gives us the strength of that correlation. And then in this last one, R is 0.190, and that's fairly close to 0. You can see our points are kind of all over the place, so there's really no correlation there. So let's take a look at an example and see what that looks like. All right, so we have the numbers of alternative fuel vehicles, V, in use in the United States from 1992 to 1999, and they're shown in the table below, or next to the problem. All right, so we've got your 1992 to 1999 number of vehicles. Construct a scatter plot for the data given. Be sure to label the axes and give the graph a title. Then find the least squares regression line, and we'll do that on the calculator. Describe the correlation and the meaning of the slope and y-intercept in context of the problem and explain the correlation coefficient. Okay, so first I'm going to number my years, and I'm going to make every line on my x-axis 1 unit or 1 year. And so I'm going to start with the year 1990. And so my first line would be 91, 92, 3, 4, 5, 6, 7, 8, 9. Okay, and so this is the year where the year 0 equals the year 1990. Okay. And then here I'm going to start with 20, and we'll go 22. Well, that's really kind of hard to see. So go 20, 22, so then 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, and this is the number of vehicles in 10,000s. All right, in 10,000s. So this would be 200,000. Well, we'll just do this. All right, so then we're going to label our y-axis, and I'm going to start here at 200. And so then that would be 220, 240, 260, 280. So then here we'll have 300, 320, 340, 360, 380, 400, 420, 440, 460, 480, and then 500. And this is the number of vehicles in thousands. All right, so now we can graph our scatter plot. All right, and so we're going to take each of those ordered pairs and we are going to graph them. And so we've got in the year 1992, it was 251,352. And so that would give us, let's see, somewhere around there would be a point. In 1993, it was 314,000. So that's going to be up here. Remember that every line is a 20,000, every horizontal line. So in 1994, I had 324,000. In 1995, I had 333,000. So that's going to be up there. 1996 was 352,000. 1997 was 367,000. Let's see, 1998 was 383,000. And 1999 was 407,000. And so that looks pretty linear to me. So let's take a look at what the calculator gives us when we run our linear regression. Okay, and I'll show you in class how to actually type this into the calculator. But the first thing I've done is I've typed in my my units or my ordered pairs into a table using 2 for 1992, 3 for 1993, and so on. And then I plugged in the values for how many vehicles there were into the other table or the other list. And then I ran, so then once you have it put into your table, you hit your Stat button and go over to Calc. And then you're going to go down to number 4, linear regression. Okay, and so I'm going to run that, and I end up with the equation y equals 18,891 point, we'll say 18 x plus 237,980.64. Now we really could have rounded to the nearest whole unit. That might make more sense in context of the problem. Okay, and our R value, our correlation coefficient is 0.964. And so that is a strong positive correlation. And you could kind of see that on the graph. Our points are pretty pretty linear there. And they are going up as X increases, Y is increasing. Okay, and so then the last part, we need to talk about what is the slope. Okay, so the slope means that that the number of cars increases by 18,891 for every year. Okay, and the y-intercept means that the starting point, when they first started making these vehicles, there were about 237,000, that number doesn't look right, 237,980. I forgot my zero there. There we go. There were about that many that were purchased and being driven. And so now we can use this model to kind of make predictions about how many vehicles might be out there in, say, the year 19, well, not 19, we're in the 2000s, so maybe like 2020. We could continue with that and see if the model works for that.